Today we discuss about optics introduction. First of all, we know about what is optics, the branch of physics which deals with the behavior of light and other electromagnetic waves is known as optics. And next one, in this optics definition we have a light word. First of all, we know about light, and after that we know about the properties of light. So first, light. Light is a form of radiant energy that can cause the sensation of vision by a normal human eye. And the light properties we can give. The wavelength range of light is from 400 nanometer to 750 nanometer. Next one, the speed of light in vacuum is 3 into 10 power 8 meter per second. And next one, light can travel in solids, liquids and gases also. And to solve the numericals on light speed, frequency and wavelength, there is a relationship. That relationship is C is equal to F lambda, where C is light speed, F is frequency of light and lambda is wavelength. And next one, we know about the properties of light. And the properties of light mainly rectilinear propagation of light, reflection, refraction, double refraction, interference, diffraction, polarization and photoelectric effect, etc. To explain these properties, many theories about the nature of light are proposed. First, we know about the theory's main points. First one, the corpuscular theory. And this theory was proposed by Newton. According to this theory, the light consists of small weightless particles which are called corpuscles. The color of light is due to the different sizes of corpuscles. This theory explains the rectilinear propagation of light and reflection, but it cannot explain the remaining properties of light. And second one, the wave theory of light. The wave theory of light was proposed by Huygens. According to this theory, light has a longitudinal waveform. For the propagation of light, medium is necessary. So, he can assume that universe is spread by a medium that is known as ether. And the color of light is due to the different wavelengths of light. And this theory can explain rectilinear propagation of light, reflection, refraction, interference and diffraction. Remaining properties of light are not explained by this theory. And third one is electromagnetic wave theory. And this theory was proposed by Maxwell. And according to this theory, light travels in the form of electromagnetic waves. And these electromagnetic waves are composed of electric and magnetic fields oscillating mutually perpendicular and also perpendicular to the direction of propagation. The presence of ether is not needed. It explains all the properties of light except photoelectric effect and Compton effect. And last one is the quantum theory. Max Planck proposed this theory. Light was considered in the form of small pockets of energy called photons. It explains photoelectric effect and Compton effect. The remaining properties of light are not explained by this theory. So from this theories of light, finally scientists conclude that light has a dual nature, that is a particle as well as a wave nature. If the wavelength of light is negligible compared with the object size, then the particle nature of light is dominated. By using this nature of light, we can explain rectilinear propagation of light, reflection, refraction, and etc. So, the branch of physics which deals with the particle nature of light is known as geometrical optics or ray optics. So, in this way, we can get one separate branch from optics. Next one, if the wavelength of light is comparable to or more than the object size, the wave nature of light is dominated. By using this nature of light, we can explain the interference, diffraction, polarization, and etc. So, the branch of physics which deals with the wave nature of light is known as wave optics or physical optics. So, to understand the wave optics or geometrical optics, we need some definitions. So, first one, we know about polychromatic light. The light which consists of a mixture of wavelengths is called polychromatic light. Example, white light. Next one, monochromatic light. Light of a single wavelength is called monochromatic light. Example, laser light. Next one is luminous object. The object which gives out light energy by itself is called a luminous object. Next one is a non-luminous object. The object which does not give light energy by itself but reflect light falling on it is called a non-luminous object. Next is a wavefront. Wavefront is the locus of all points at which the phase of vibration of a physical quantity like a pressure and electric field is the same. Next is a ray. The path along which light energy travels in a given direction is called a ray of light. Next, beam. A collection of number of rays of light is called a beam of light. So, to understand the difference between a ray and a beam of light, once observe the diagram. And next one, optical medium. Anything through which light energy can pass is called optical medium. Next one, homogeneous medium. If an optical medium has a uniform composition throughout, it is called a homogeneous medium. Example, vacuum, glass, distilled water, etc. Next one is a heterogeneous medium. If an optical medium has a different composition at different points, then it is called a heterogeneous medium. Example, air, dirty water, etc. Next one is a transparent medium. A medium which allows most of the light energy to pass through it is called a transparent medium. In such a medium, we can see through clearly. Example, air, glass, plastic, etc. Next one is a translucent medium. A medium which allows only small part of light energy through it is called translucent medium. In such a medium, we cannot see through clearly. Example, frosted glass, greased paper, dirty water, etc. Next one is opaque object. The object which does not allow the light energy to pass through it is called opaque object. This type of object either absorb or reflect the light energy. Example, bricks, wood, stones, etc. Next one is a real object. If the rays incident on the reflecting or refracting surface are diverging from a point, then the point is the real object. Virtual object. If the rays incident on the reflecting or refracting surface do not start from a point but appear to converge at a point, then that point is known as a virtual object. And to understand the real object and virtual objects, there is a small diagram. Observe that diagram. Next one is real and virtual images. If the rays converge at a point after an interaction with the surface, then a real image will be formed. And if the rays diverge after an interaction with a surface, a virtual image will be formed. And observe the diagram. In figure A, the object is real and image is virtual. In figure B, the object is virtual while the image is real. And based on this introduction points of optics, we have some level 2 theoretical questions. Observe that theoretical questions. First question, the idea of the quantum nature of light has emerged in an attempt to explain. Option A, interference. Option B, diffraction. Option C, radiation spectrum of black body. Option D, polarization. And here the answer is C, option C. And question 2, the phenomenon of interference is shown by option A, longitudinal mechanical waves only, and option B, transverse mechanical waves only, option C, electromagnetic waves only, option D, all the above types of waves. And for this, correct option is D. So option D is correct. And question 3, light appears to travel in straight lines since option A, it is not absorbed by the atmosphere. Option B, it is reflected by the atmosphere. Option C, its wavelength is very small. Option D, its velocity is very large. And the correct option is C. Question 4, which of the following statements indicates that light waves are transverse? Option A, light waves can travel in a vacuum. Option B, light waves show interference. Option C, light waves can be polarized. Option D, light waves can be diffracted. So for this, option C is correct. Question 5, wavelength of light of frequency 100 Hz is. So here we can find out wavelength, and before going to that wavelength options, option A 2 into 10 power 6 meters, option B 3 into 10 power 6 meters, option C 4 into 10 power 6 meters, option D 5 into 10 power 6 meters. So to find out the wavelength, we can use C is equal to F lambda, and C is taken as 3 into 10 power 8 and F is 100 Hz. By applying the values, we can get a wavelength value. That wavelength is 3 into 10 power 6 meter. That is option B. Next, question 6. Newton postulated Corpuscular theory on the basis of option A. Newton's rings, option B. Colors of thin films, and option C. Rectilinear propagation of light, option D. Dispersion of white light. So the correct option is C. Question 7. The dual nature of light is exhibited by option A. Photoelectric effect, option B. Refraction and interference, option C. Diffraction and reflection, option D. Diffraction and photoelectric effect. So the correct option is D. And question 8. Which of the following is not a property of light? Option A. It requires a material medium for propagation. And option B. It can travel through vacuum. And option C. It involves transportation of energy. Option D. It has a finite speed. So the correct option is A. And question 9. Select the right option in the following. Christian Huygens, a contemporary of Newton, established the wave theory of light by assuming that light waves were transverse. And option B. Maxwell provided the compelling theoretical evidence that light is a transverse wave. And option C. Thomas Young experimentally proved the wave behavior of light and Huygens assumption. And option D. All the statements given above correctly answers the question, what is light? So by observing the options, the correct option is taken as B. So this is about optics introduction. Thank you.